In this video, we're going to explore the greatest common factor and how it applies to factoring. So on the first three questions here, we want to find the GCF, that's the abbreviation we're going to use for greatest common factor of each of the polynomials. So greatest common factor is the number or variable, but most for our purposes today, number, the largest number that everything has in common. So if I'm looking at number 1, I've got 8x squared minus 8x and minus 48. It is true that they have a lot of numbers in common. 2, 4, 8. But what we're really interested in is finding the largest number that all three of these have in common. Not 2, but all three of them that are factors. So if I'm looking at 8, I'm thinking that the greatest common factor is 8, and I'm just going to verify that that's actually true. 8 can be broken down to 8 and 1, and so can that 8. And this 48, that's really the game changer here. Is this divisible by 8? And it is. 48 can be broken down to 8 and 6. So the greatest common factor of these terms is 8. In the second one, we have 4x squared minus 44x plus 120. So I'm seeing a 4 here, and that's kind of tipping me off that maybe 4 is my greatest common factor. So 4 definitely does go into 44, and it definitely goes into 120 as well. So my greatest common factor would be 4. And on the third one, I'm seeing a 6. So I'm thinking, oh yeah, these are all divisible by 6. Turns out they're not. Only one of them is divisible by 6. 15 and 21 are not divisible by 6, so I can't do anything with those. However, I can divide a 3 out, so I can take 6 and break it into 3 and 2, 15 into 5 and 3, and 21 into 7 and 3. So it's going to be 3 as the greatest common factor. Now that's the first step in the process. The next step is, let's take the greatest common factor out. So we'll do a couple problems together here. We have 8x squared, negative 36x, and negative 20. And I'm looking to take out the greatest common factor. So I'm looking at these problems here. I'm thinking 8 was my original thought, but 8 doesn't go into 36 or 20. And the reason I'm keying in at 8 is that's my smallest number that's there. So then I'm going to look for something smaller that goes into 8, like 4. So 4 goes into here, 4 goes into all of those. So my greatest common factor then would be 4. But I'm not just finding the greatest common factor, I want to take that out. So we want to think about a question like this. If I started with a problem like 3 times 2x minus 1, if I were to do something with that, most likely my thought would be to distribute. Take that number and multiply through. 6x minus 3. And the reality is when we're factoring with the greatest common factor, essentially we're doing reverse distribution. We're taking a number out when it was already in. So if I take 4 out, we're trying to think, when I have 8x squared, what will that turn into? Well, if I divide by 4, I get 2x squared. When I have negative 36x and I divide it by 4, I get negative 9x. And when I have negative 20 divided by 4, I get negative 5. So I've factored out the greatest common factor. We're going to do the same thing on the second problem. We have 60x squared plus 114x plus 36. So my smallest number here is 36, and clearly that's not going to go into all those numbers. It would be lovely if it did, but it's not that easy. So we're going to think of some numbers that can be divisible by really going to key on these the first and the last term, the 36 and the 60. So if I'm thinking of 36 and what it can break down into, I'm thinking maybe 9 and 4, but I definitely can't take a 9 out of 60. 4 is a possibility, and it might work. We'll see. Maybe I could do 3 and 12. I'm pretty sure I can take a 3 out of all of those terms. Let's see what happens if I do that. So let's take a 3 out of the first term. So that would give me a 20x squared. And if I'm taking a 3 out of 114, and I'm going to cheat here. I'm going to use my calculator. 114 divided by 3 is 38. And then 36 would become 12. So looking at what's left, I want to see, is that it? Or does what's left have something in common? And they actually do. 20x squared, 38x, and 12 all have a 2 in common. So I'm going to take that out in addition to the 3 that's already out there. So when I do that, I figure out what am I going to do with the 3 and the 2. We'll just kind of leave it there for now. By taking that 2 out, I get a 10, a 19. Now that's a prime number, so I'm pretty sure I'm done after this, and a 6. Well, the question then becomes, what do we do with that 2 and that 3 that are outside? Well, think of this when we did radicals. If you simplified a radical and there was something out there already, so if I gave you something like 2 root 8, and you broke that down to root 4 and root 2, that square root of 4 became 2, and it got multiplied by what was out there. We're going to do the same thing with the greatest common factor. So outside, I should have 6. Well, what that tells me is I probably could have taken out a 6 right away as my greatest common factor. And really the way I know that is by looking at what's left. Here I had numbers that had a common factor, 20, 38, and 12. They have a 2, clearly. Here I didn't. 10, 19, and 6 don't. 19 is a prime number, so that's it. There's not much else we can do with it. So let's look at what's the next step in this once that stuff's done. The next step is going to be taking what we have. We took out our greatest common factor, and then from there, factoring what's left. Now, either use the area model or use the guess and check method that we explored in the previous video. But the idea here is that with 2x squared minus 9x minus 5 can be broken down to x minus 5 and 2x plus 1. And eventually what we're going to do is solve these, but we're not there yet. We're just factoring with the greatest common factor. So on questions 3 and 4, we have already done the taking out the greatest common factor already. Now we're just going to say, all right, well, this is what we have left. So I have x squared minus 3x minus 4, and I want to factor that. So to do that, I'm going to just go ahead and use guess and check because I think it's a pretty efficient method if I'm smart about my guessing and checking. And to get x squared, I need x and x. To multiply to get negative 4, I have a few options. One option is negative 2 and 2. I don't like that one in this case because I think something else is going on here. If we've got that negative 4, the other option is a negative 4 and 1. And so if I try that, if I multiply these together, I get negative 4x. And if I multiply the outside pieces together, I get a 1x, which would add up to negative 3x. So it works. Now, if I were to put that on an assessment, I'd be close, but I forgot something. Remember, I already took that 12 out. That was my greatest common factor. Again, it is a factor. It's in the name, greatest common factor. So I should have that 12 out in front. And I think what ends up happening is a lot of times we get so hung up on the factor. We're like, oh my gosh, I've got to factor this polynomial. And we forget about that greatest common factor that we took out. It happens to the best of us. It happens to me pretty regularly. So let's look at number 6, or actually let's look at 5. I think that's a unique one, kind of a cool special case. So again, a 90x squared minus 10, our greatest common factor is 10. So when we factor that out, we're left with 9x squared minus 1. So our next step is going to be to factor 9x squared minus 1. So I'm going to do that by guessing, strategizing, that when I have 9x squared, I'm thinking that I'm probably going to have a 3x and a 3x. And when I have a negative 1, I got really limited options here. I think I'm going to do a plus 1 and a minus 1. Now, what happens in this is when I were to check it, the x terms cancel. That's what I want. I don't have an x term. I just have 9x squared, and I have my negative 1. So that is the end result of my product, or my factor. There it is. And a question like number 6, the challenge on this is the fact that you have a 7 out in front, so those numbers get kind of crazy. So guessing and checking, I'm going to do a 7x and an x. And my instincts tell me I probably should do 5 and 4 because of the fact that those are the closest factors together. So I'm going to try a 5 here. Let's just do a plus 5 and a minus 4, and let's see what happens. So this gives me a 5x And this gives me a negative 28. That doesn't give me 4. And I think if I flip the 5 and the 4, I still don't think I'm going to be there, because I'm going to have 35 and negative 4 is 31. That's not right. So instead of 5 and 4, I'm going to try a different combination of 20. I'm going to go with a 10 and a 2. And I'm going to go minus 10 and a plus 2. Because when I take 7 times 2, I get positive 14. And negative 10 times x is negative 10x. Together, that gives me 4x. And that's what I wanted. So there's my completed factor problem. 4 times quantity 7x minus 10 times x plus 2. Now, the reality is when we're factoring, we're never going to say, hey, factor by the greatest common factor. No, we're going to say factor it. The first thing we should be looking for when we're solving is to take the greatest common factor. So that's basically a summarization here. When we're finding, when we're factoring, we're always going to look for that greatest common factor first. Then, if there is no greatest common factor, then factor as you would. So when you take something out, look at what's left. If there's no greatest common factor, then do what we've been doing, which is to just go ahead and factor it. If there is a greatest common factor still left, then you need to take that out. You probably didn't find the greatest common factor. You just found a factor. No big deal. Just keep going.